Remember, if it can't be grown, then it has to be mined.
Minerals and metals are building blocks of all new technologies and all actually existing technologies.
Reports estimate that mining comminution takes about 3 to 4% of the global energy budget. So it's a massive energy draw. It's also, at the same time, very, very inefficient.
Developing new comminution processes is so expensive and the timeline for adoption so long that very few people are bold enough to start the journey.
KenMicro is transformative because we use microwaves to transmit energy directly to the desired location of breakage in rocks and to sort ores to remove barren material prior to grinding. Lucky for us in mineral processing, valuable minerals typically heat well upon microwave exposure, whereas low-value minerals do not. So microwave treatment of ores results in the differential thermal expansion of mineral grains, yielding fracture along grain boundaries, and also gives rocks containing valuable minerals a thermal signature. In KenMicro, we use these effects to reduce ore competency, selectively liberate valuable minerals, and to sort ore particles so that waste rock can be rejected before grinding.
TCO2 is innovative in the sense that it uses a completely different principle for breaking rock than traditional mechanical comminutions. We formulated this idea where we would put the rock in a chamber, we would inject CO2, we would compress the volume inside the chamber. The CO2 would permeate through the rock rapidly because it's now in a supercritical state, and then we rapidly decompress the chamber below the critical threshold. That process of rapidly decompressing the chamber causes the CO2 to rapidly expand, and that rapid expansion then permeates throughout the rock and you shatter the rock from within.
Everybody has at heart to design more eco-efficient flow sheets. But it is a very complex problem, composed of multiple input variables, extensive equipment options, and multiple flowsheet configurations. This is what IntelliCrush will deliver. Artificial intelligence is about decision-making. Corem, Ivado, and BBA will provide years of comminution test data, flowsheet designs, and AI algorithms know-how, a winning foundation for IntelliCrush. We will use it to evolve optimal circuits, and we will use it to establish the best sequence of tests and decisions to design eco-efficient flow sheets.
High-pressure grinding rolls, or HPGR, use compression, the most energy-efficient approach to grinding currently known. Recently, this technology has been increasingly adopted by the mining industry. However, it is mostly limited to primary grinding in replacement of SAG mills. The ore is still brought to its final size by very energy-inefficient ball mills, which consume approximately half the grinding energy in a circuit. We want to demonstrate that HPGR can also replace ball mills.
CMIC and its members identified energy in comminution as a key challenge and agreed to collaborate and find a solution. A global technology scan identified 26 technologies, with CAM being the only one that showed remarkable potential for significant energy reduction and readiness for commercialization.
The outer anvil ring has pockets at its inner surface. The inner hammer ring has protrusions that mesh with the anvil pockets as the rings rotate in unison. Ore feeds from both ends, above the hammer, and flows into the gap between the rings. Large rocks are broken by point loading. Small rocks and fragments flow into the pockets and are crushed by the hammers. Hammers then push fractured rocks through the bottom slot in each pocket and into a collection chute. Gravity and hydraulic pistons apply the hammer rock breaking force.
Our innovation, SHOT, selectively weakens ore right at the boundary between the valuable grain mineral and the waste or host rock gang.
When minerals heat, they expand, and this expansion causes fracture at the grain boundary that can lead to reduced ore competency and enhanced liberation. These mechanisms offer the opportunity to reduce comminution energy requirements, increase throughput, increase grind size, and increase valuable metal recovery.
The Crush It Challenge was a great opportunity to apply shot technology to specific Canadian ores. It was great to be able to demonstrate the applicability of shot technology to Canadian miners.
One of the challenges with microwave technology is that you can't demonstrate energy savings at the bench scale. You need to go big, you need to have high tonnage, you need to have high power. It's a big jump from, something that looks like a kitchen microwave to 150 kilowatts. So the influx of cash from NRCan allowed us to advance the technology more quickly than we otherwise would have been able to.
We started off with this project as a team of 3 from Envision Labs, but over the project we were able to grow that team from 3 to almost more than 10 people.
It's really the Crush It Challenge that really provided that spark that allowed us to turn the idea into a project.
Great opportunity to advance our technologies, but also as innovator, we are very excited by what we've seen from the other project.
I strongly recommend this model as applied to other areas in the mining industry innovation ecosystem needing rapid and transformative change.